Okay, this is the tutorial for Euclid's Elements, Book 1, Proposition 1. We're going to go through the entire proof and then point out some key points along the way. We're just going to read the text as we move along. The enunciation is to construct an equilateral triangle on any given finite straight line. So, as a reminder, the enunciation just means what is it that we're going to be able to do by the end of this proof, or what is it that we're going to prove by the end of this proof. And in this case, we're going to make an equilateral triangle with all three sides equal to each other on any given segment. Now the given is AB, which is a segment. It's a finite straight line. And it doesn't matter where this is. So I'm going to go ahead and put point A and point B, and I'm going to make that segment. And now we must construct an equilateral triangle on the segment AB. So follow along. I'm going to read the 4 steps of the construction and then go over what we did. Then I'm going to read the proof and the conclusion. So step 1, we're going to construct circle BCD with center A and radius AB. So we're going to make a circle with center A and radius AB, that's this. There we go. And I'm going to make this one red just so it's very visible for us. So the red circle is circle BCD. Even though we only have point B so far, we also know that point C and point D are somewhere on that circle. Now, step 2, construct the circle ACE with center B and radius BA. So that's the same radius but starting from point B, and that's going to cut the circle BCD, the red circle, at point C. So I make that circle, and I'll make it blue just so it's visible. Again, this is circle ACE because point A is on it, point C is on it somewhere, and point E is on it somewhere. And it also tells us in step 2 that the circle ACE and the circle BCD cut each other or intersect at point C. So I'm going to label point C. I can label that intersection up here or down here. Let's do it up here. Perfect. So point C is the intersection of those two circles. Step 3, connect segments CA and CB. I'm going to go ahead and connect CA and CB. Now one thing I want to point out here is that in these 3 steps we used postulate 1, 3 2 times and postulate 1, 1. Those are the statements in the square brackets. Anything in square brackets is basically reasons or proof that we're allowed to do what we're doing or saying, but the proof isn't there in the text. It's something that's already been proven. So postulate 1, 3 says that we're able to make a circle, and postulate 1, 1 says we're able to make a segment. So we made our circles and we made our segments because we had those postulates. Step 4 says we claim that ABC, the triangle, is the required equilateral triangle. So we've made our construction, we're not going to build anything else. We just need to prove that what we've built is what we said it was, the equilateral triangle. So now we're going to go ahead and go through the proof. So the proof, point A is the center of BCD, the red circle. That means that AC equals AB. Now that's because these two are radiuses. So for example, AC is the radius of this red circle, and so is AB. And we know that radiuses are equal to each other. So that's why we're allowed to say what we did right here. That's step 5. Now step 6 says that point B is the center of ACE, the blue circle, so BC equals BA. Now I want to point out that AB and BA are the same line, and BC and AB are both radii or radiuses for the blue circle. Step 7. we already proved that AB equals AC. And we just proved that AB, or that's BA, that's the same thing, is equal to BC. So that means that AB is equal to two different things here. AB equals AC, and AB equals BC. So we know that we can use common notion 1. Step 8. Things which are equal to the same thing are also equal to one another. So AC equals BC. So this one, AC, equals BC. So step 8 says AC equals BC. And both of those are equal to AB. So let's take a look at what we just proved. We proved that AC and AB are equal to each other because they're the radii. We also proved that BC is equal to AB because they're the radii of a different circle. And we proved that since both of these, AC and BC, are equal to AB, all three of them are equal to each other. That means that we have an equilateral triangle, since the definition of an equilateral triangle is that it is three equal sides. So now the reflection questions are on the back of your paper, and you should be answering them. Good luck, and if you have any questions, make sure you just drop me a line with the phone number on your syllabus or on the email on your syllabus.